Welcome everyone. Thank you for joining us today. If you hear me well, please write something in the chat. For those who don't know me, my name is Alexander Plachikov. I'm from Poland, Krakow. And today I'm in role of moderator for a special talk that we have. And today I joined by Evgeny Kovalov. Evgeny is a lead software engineer. Hi, Evgeny, from EPAM. Evgeny is working with Kotlin, and he's going to present a special talk related annotation processing and Kotlin symbol processing. And Evgeny presented, and I guarantee that by the end of this talk, you will walk away with understanding how annotation processing works. And before we move on, I would like to mention that we have a live chat here on YouTube. If you joined from via community, please find a link to YouTube channel and write comments here in YouTube channel. At the end of the talk, we have ample time, and we can, let's say, find some interesting pop up in them, and I delegate this question to Evgeny. Yeah, do not hesitate to write anything, put your reactions, give your likes, even dislikes. Yeah, we really appreciate for any reaction. And yeah, let's make this talk more engaging and more useful for everyone. So, Evgeny, before we move on, a little question from you. As I know, you recently relocated from Belarus to Lithuania to Poland finally. And in Poland, what surprised you?
Surprised me? Well, I don't know. Yeah, before my relocation, I've already been to Poland. So yeah, it was quite a familiar step for me. But yeah, in general, I would say that I like it better than Lithuania. Sorry, my Lithuanian colleagues. Yeah, but yeah, I like it better. I don't know. It's kind of a vibe, and the language for me is easier than Lithuanian. Lithuanian is just, it's really hard. I would say like that.
Yeah, it seems that your process of adaptation is running smoothly.
Yeah,
Okay.
more or less, yeah.
Yeah, by the way, we represent mobile people community in Poland. Yeah, please subscribe our channels, and also do not hesitate to, let's say, participate in our talks. So let's move on to the topic. The stage is yours, Evgeny. Please present your talk.
Yeah, okay. I hope everyone can see my screen. I'm sharing right now. So yeah, a short disclaimer just before we start. Yeah, as Alex said, I've relocated from Lithuania, and this talk have been already given for the Vilnius Kotlin user group community. So there could be references to this community, especially the source code for the talk could be found on their GitHub page, but it's open source and you can check it out later. But other than that, everything is all right. And yeah, we can start. Before we start, I also want to say that I have a small riddle for you at the end of this talk, and there are two clues inside this talk, inside the slides, that could help you with solving this riddle. The first one you can see right now. This person at the right side of this slide. Please take a careful look at how it looks like, what he wears, what he holds, and in general, just remember his appearance here, and it could help you at the end. Yeah, just one more time. My name is Evgeny. I'm lead software engineer at EPAM Systems. More than 10 years of mobile experience behind my shoulders. And yeah, I'm passionate to the best design in every respect. So what our goal today, actually, we want to find out what is annotation processing in general, how Java and Kotlin annotation processing work, what is the difference between Java annotation processing tool and KSP, why KSP was introduced. Then we will try to take a quick code review of let's say, semi-real KSP usage, but it's still valuable one. At the end, we will see some best practices that we can take from this example, and we will make a conclusions and kind of a decision-making framework when you need or should not use any annotation processing tool. And yes, at the end, I will be happy to answer your questions. Okay, so let's get started. Annotation processing. So what is that? Well, actually, when we write the code, right, we need a compiler to compile this code. And compiler have different stages of compilation. For example, analyzation stage, where the compiler could build some syntax trees and analyze if this is right or wrong. And there are more stages, but yeah, let's be short and focus on this one, generate code. Some modern compilers have this stage. So what is this stage about, actually? When I'm saying modern compilers, we can talk about these languages. You can see here it is part of the compilers for these languages, but it is not the whole list. The list is bigger than just these languages. But the concept itself, which the compiler is support, names metaprogramming. Metaprogramming apparently is a paradigm. The same paradigm as functional, imperative, or object-oriented. And what is the key idea of it? So for the metaprogramming, we should have some source code, which is an input for our program, which is working in this paradigm. And as an output of this program, we have some modified source code. So it sounds like we can take some source code, which you write, and produce some more code, or a little bit change your code while you're writing this code. So who has seen this show presented on MTV channel should understand what this picture referring to. But yeah, that sounds crazy, but that's true. So basically, it works like that, yes? And what are the use cases? So there are four more main categories of the use cases. The first one is code generation. A lot of dependency injection frameworks working like that. So using the annotations and annotation processing, we can leave the instructions for the compiler, which classes and how we want to generate to provide our dependencies. We can have a validation use case. I'm coming from mobile world, so we have annotations which could check that you actually have reference to some resource. So in code, you identify it with annotation that we're referring, for example, string resource or drawable resource or something like that. And during the compilation stage, the compiler will check it for you. Configuration. If you're familiar with some object relational mappings and database configurations, that's the case. You can put the annotation which will configure your database schema or your tables or your primary keys, etc. And performance optimization, this is kind of a not so often example, but if you remember a problem with auto-boxing in Java or JVM, there were some annotations that could check it for you too. It's kind of validation, but at the same time, these annotations that day could not only check, but correct it for you and fix. So yeah, that's it for the term in general. Let's take a look at Java annotation processing. So if you can recall this slide, for the Java, we have a Java compiler, which is Java C file, which is delivered to you in a JDK. And according to the open JDK, these stages called parse and enter, annotation processing, analyze and generate. So as I already said, parse and enter, this is a stage when the compiler builds syntax trees and other trees it requires, work and check the syntaxes, and provides this syntax tree to lint and lint tool and other tools which require it. Annotation processes, this is a stage we will discuss a little bit later, and analyze and generate, this is actual compilation stage where compiler analyzes the whole source code, checks dependencies, whatsoever, right? So yeah, the compilation stage, we can also subdivide it to precompile and compile. So on the precompile, yes, parse and enter, abstract syntax tree. From here, you can get syntax errors. During the annotation processing, we can produce more source code. And if we see something in our annotation processor, we can produce warnings and errors. And then this stage analyze and generate, we have actual compilation errors. As I said, I will repeat myself, sorry for that. But if you don't have a dependency in your class path, only at that stage you will have these kind of errors. So yeah, what we do with this stage when we produce more source code, we can't leave it as is. Yes, this code also should go through the stages of syntax tree and analyzing the syntaxes and everything. So there is a new round of analyzation every time you produce some more source code. All right, so building blocks. How can we write a Java annotation processor? So there are 7 steps. We will go through all of them right now. As I said, the source code for this talk is open source. It's available. I will provide you links at the end. And this is how the project looks like. I'm using Gradle as a build system for this project. And we have a sample with a root which is a root project, and we have 2 modules in it. It's annotation module and processor module. So that's the structure of this sample. So first, we define our custom annotation. We named it mobile people printer. You will get it later. Why is it called in that manner? We put target and retention annotations here. So these are provided by the JDK and Java. So target means that we annotate element types parameters. So actually we annotate parameters of the functions or constructors. And retention, this retention policy, this is actually the command to a compiler when this annotation could be retained or basically cut off from the source code. So in our case, it's retention policy source, which means that while we compile at the final artifact, in the final artifact, these annotations would be cut off and not present in the binaries. The next step is to extend abstract processor. Again, this is provided by JDK. And we have to override here init method. This method has processing environment as an argument. Processing environment is basically your source code. And you could have your source code for tests. You can have your source code for your production code. You can divide your source code base to many different pieces, right? And each of these pieces will be treated by the compiler as a separate processing environment, and you don't have any interconnections between them. So inside this method, we can get some utils and valuable elements of the APIs from the environment itself. So element utils and type utils, these are the utils which allows you to work in a more simpler manner with the elements and types in your syntax tree or a tree, abstract tree, which compiler provides to you. Filer is a class or object which allows you to create files and write data into them, basically write code into them. And messenger is kind of a object which allows us to communicate some warnings and errors to console and thus to the user of our processor. Right. The next step, we need to override these 2 methods. They are self-explanatory. So get supported annotation types. We provide a set of annotations we handle in our processor. For the source version, we provide the latest supported version of the Java processor should work with. After that, we actually provide our processing logic in a method called process. So we get a set of annotations and a round environment. As I already said, we could have several rounds of processing. And here, this method returns a value. So it basically controls whether subsequent processes should handle this annotation or not. In a subsequent round or in this current round, it doesn't matter. So this Boolean just controls it. And as you can see, our logic here is pretty simple. We get all elements annotated with our annotation, and we print it to the console output. So that might be it, but no. We need to register our processor in metainf/services directory. Basically, compiler needs to know which processors it works with. So that's the reason why we need to provide this data. So we need to create a file there and provide a full class path to our annotation processor. But some clever people a long time ago decided that this routine could be automated with the help of annotation processor. So we can use an auto-service annotation provided by these dependencies you can see above. So it's auto-service dependency. And when we do that and we build our processor, we'll have it generated by ourselves. As you can see, this annotation process inside our processor generates this file for us. And that's really useful and convenient way to work with that. Afterwards, we need to build a jar and input into the project. This jar or artifact will have our processor. In our case, we have it all defined and written in our sample. So we just point the right dependencies. And after that, in our source code, if we have something like that, we have a method named doNothing where we annotate all the parameters. During the build stage, we will see this in a compile Java step of Gradle build process. So nothing special. We just print out all of our parameters from our function. Kotlin annotation processing. So for Java, it has this look. For Kotlin, almost the same, except we have Kotlin compiler involved, and we have additional step, really important one, which is IR generation. So IR generation, IR stands for intermediate representation, and this is basically how Kotlin converts itself to the Java bytecode. So this is some kind of a intermediate way of creating Java files, right, from Kotlin ones. Okay, so for Kotlin, it will be pretty much the same abstract syntax tree and syntax errors, the same stage for generating more source code, the errors from our annotation processor, and from IR generation and from bytecode generation, we could have some compilation errors. The same way, if we generate some more code, it should go through all of the stages from the beginning. And when we build a Kotlin annotation processor or an annotation processor for Kotlin, it depends whether you're using Kotlin or Java. Just because Java annotation processors are compatible with Kotlin. And if you write your annotation processor in Kotlin, then the first step will be different. You need to use Kotlin's target and retention annotations just because Java ones doesn't work. And that's it. If you write it in Java, well, in Kotlin project, you will have to use KAPT for annotation processor, not APT. And that's it. Everything else looks the same. So yeah, what are the pros and cons for the annotation processor for Java and Kotlin? So yeah, as you can already, we can already make a conclusion that Kotlin annotation processor doesn't bring anything new. So it's just compatible with the Java one. And it is part of the compiler, which means that we have kind of a stable API, and this API will not change with the language upgrades or something like that. When you, not kind of a language upgrade, but it will be consistent, right? If Java is increased, Java version is increased on your project, with a high probability, the previous version will still work. We have a flexibility and access to abstract syntax tree. So this is also kind of a powerful thing. A lot of APIs available there. So yeah, if you're familiar with that, you can do some some interesting stuff there too. But as a cons, well, it makes build slower, right? And Kotlin, just because Java annotation processor should work with the Java files, Kotlin generates Java stubs from Kotlin files for the Java annotation processor to work with Kotlin code as with Java. Without generating stubs, it is not possible. So that step makes it slower, especially for Kotlin. Build tooling can't do any optimizations when we work with Java annotation processing. So that's also a cons. And which is more important for us, Java annotation processor doesn't know anything about Kotlin specifics. If you have data classes, sealed interfaces, and stuff like that, well, Java annotation processor can't handle it. And it might be really valuable if we write some processor which relies on the Kotlin features. So that's why Kotlin Symbolic Processing was introduced by JetBrains. And they saying that it is faster up to 2 times than Java annotation processor. And they also say that it is built on compiler plugin API. If you read it from their side, that's mostly all the information available to you. But rationally, we can say, like after working with that, I can say that, yes, it is faster, but we don't expect 2 times boost. Just because, as I said, it really depends on the use case. If your annotation processing logic takes a little time compared to the time which is taken by the Kotlin compiler to generate these stubs for Java, yeah, in that case, you will see significant boost. But otherwise, yeah, it is debatable. KSP understands Kotlin-only semantics, and this is really great. It has a simplified API, which is also great because you don't need to know a lot of stuff, how to work with types, elements, how to find something you need. So the API is, let's say, more concise. And it is not tied to JVM. So KSP supports cross-platform, and you can use it for a native. You can use it for web, for desktop. These KSP processes, they will work. Well, this KSP API is quite new. If you have worked only with Java annotation processing, you will have to learn this new API. And this API, it is limited. So it doesn't provide you the full power which we had with Java processing, annotation processing. But mostly, the new API covers pretty much all of the use cases. So yeah, and KSP doesn't provide the same flexibility as compiler plugins. So what I mean by that is that compiler plugins can edit your code. Like you write some code, you run the compiler plugin can edit some source codes for you, like some classes you wrote. Right. KSP itself can only generate new code. It can't edit it. So this is kind of a limitation. But, well, again, this is arguable. Usually, when you need some kind of these changes, like changes in your source code, yes, even annotation processing is not the choice for you. All right, so yeah, KSP, as I said, based on compiler plugin API, so we don't use anything from the compiler stages here. So plugin API, we just use the API it provides for us. So KSP is the same plugin as some other plugins. So for example, if you're using Compose runtime is also a compiler plugin for Kotlin. All right, so the same picture, but here in the precompile stage, we have a KSP, which without any surprises could provide warnings and errors while working. And yes, if we generate some more source code, it will go once again through the KSP toolchain. Let's say it like that. So how can we define our KSP processor? So we have one more step here, but the steps themselves are different too. Let's go one by one through them. This is the how the project in sample looks like for the KSP. You can see the modules are pretty much the same. So first step, still the same. We create our new annotation. It is called the same, mobile people printer. It has target and retention from the Kotlin. we annotate values, value parameters. So it's again parameters, and retention is still source. Then we define our own processor. So we need to extend it from the symbol processor, and we have to write only one method here, process, which has a resolver as an input argument. So resolver provides us a resolution for any elements that were annotated in our code. So here what we do is that we go through all symbols with annotation, which has our name, and we will put it into the logger output on the info level. So empty list, so return type here, controls whether we want to pass some annotations for another round or for processor. So that's mostly it. If we return empty list, that means that we handled everything. If we return something, then the next round we will handle it once again. And this is really important in case we have a KSP processing logic, and we have a couple of processes which rely on each other and have some dependencies between each other. So one of them should wait for the other to finish its work. Yes, and we will return non-empty list here. Then we need to create then we need to create simple processor provider. In our case, it is called mobile people printed processor provider, and that's a way to create the instance of our processor. It's just a fabric. Here, this fabric takes as an input argument in create function environment, the same environment as we've seen for Java. So for different sources, you will have different environments, and the rule is the same. They don't have any intersections. You can't access source code from different environments here. After we do that, it is still possible to register our processor using the annotation, but as you can see here, we don't use apt, we use KSP dependency. And yes, the output is still the same. This annotation processor will provide a new file for us and register the service for us for the compiler. And yeah, this is the source code of our program. We again annotate these arguments, input arguments of this function. And when we build our project at the KSP Kotlin task or Gradle, we will see these output. So yeah, that's it. Now I see these samples are great, but it's better to see some real, or at least kind of a real world example of how we can use KSP. So let's do a short code review. To give you more context, the idea is next. So as a front-end developer, right, as a mobile developer, usually we are working with the JSONs provided to us from the server. So server do some logic, generate the JSON, and send us some JSON over the network. And we tend to use data transfer objects inside our applications to treat this JSON correctly, right? So we actually map it one-to-one to this data transfer object. But on different screens, on different pieces of the application, we don't need all of the fields of some DTOs and JSONs. So we can reuse the DTO, but provide some different models. And the idea is that we probably can avoid manual creation of these models. How we can annotate the DTO and some of its fields, and during the build stage, some plugin or annotation processor will do the job for us. So yeah, let's try how to do this. So here's the sample application. Hopefully you can see it. If you don't see it, yeah, Alex, please tell me. But yeah, I hope everybody can see it. So again, the source is available to you. You can check it out later and clone it from the GitHub to your machine and run. Everything works. I've checked it. Everything is all right. So here we have our DTO to module annotation. So this is basically the annotation which we will put on the DTO class. And you can see that it has the appropriate target annotation. And we can specify here a name for our model, which we're going to generate. We also add here ignoring model annotation, which is kind of a marker for us, fields we want to ignore. All right, so that's it for annotations. Processor, the main one. As you can see, there are tests, but let's check it out later. And we have our processor provider, nothing special. We register it using the annotation. And inside the create, we define how provider should create the object for us. Here's the processor itself. Here it has process function where we take our annotation, get all the symbols, and we filter instance to class declarations. So it's Kotlin sources, class declaration. This filters instance function will not only filter it, but cast the elements of this sequence to this class. And for each of the annotated classes, we call this function, which is called generate model class. Let's see what it does. So the function itself has one class declaration. It has code generator, which will generate the code for us. And it has a logger in case we want to report something to console. So we get the DTO package from the class. We get the class again from this class declaration, and we generate the new class. As you can see, as you have seen, we have a name argument there. So basically, this function here just has some logic to resolve the name for the new model, right? If we have annotation in annotation, this name argument, then we will use it. If we don't, then we have some logic around to make it pretty and look great. So we create a name for our model class. After that, we need to create a model class. And what's important here is that the way we create code, right? Every day, how we create code, we just write it. That's pretty obvious. And for the annotation processes, what we need to do, we need to generate code. How? Well, we need to write it using the code. So we need some output stream, and we need to provide some symbols to the output stream, some encoding, so the file looks okay for the compiler, and then everything will work for us. So this is kind of a trivial, and at the same time, it's kind of routine operation. So there are some frameworks or libraries that helps us to avoid this routine and boilerplate. And one of them is Kotlin Poet. There's also like a Java Poet, but another one is Kotlin Poet. This library is created by company Square, and it is open source. So this Kotlin Poet definitely will write a will write a poem for you, but it will write some code for you. So here I'm using this library to generate a type spec for a class. So I provide the model class. I build my primary constructor using the arguments of the DTO constructor. And then we just build this type spec. So when we build a primary constructor, we need to collect properties, and we do this from our class declaration. What is important here is this visitor pattern that is used. So the API in Java annotation processors and APIs in Kotlin symbolic processors, they kind of visitor ready. Let's name it visitor ready, right? So what does it mean? That you can use this pattern almost everywhere. And this is, well, this sounds pretty logical, just because we usually work with a tree. And when you traverse through the tree, you can create a visitor, which will go through all the nodes and do the stuff. So here I'm using the visitor, but the thing is that you can avoid this pattern at all, and you can traverse through the elements how you would like. But for the sake of demonstration, here's a visitor pattern, which goes through the properties of DTO class, check if they are ignored or not. And if they're not, it just adds it to a set of pairs. And this set of pairs afterwards used as an input argument for building primary constructor for our model class. And that's it. So at that step, we already created a model class, but we can go a little bit deeper, and we can create a converter function from our DTO to a model. So to do that, I've defined a build converter function method, which takes our new model class and creates a function which will generate this model class from the DTO. So again, this logic is not something special. We have constructor parameter string, which we will define, and then we build a function spec. We have to define a name, which is to model class name, right? If we have a model class named name model, then the function name will be to name model. We have a receiver, so this is a class which is a receiver of our function, extension function. We define what this function returns, and we add a statement which basically is a code. So we return, and return is a string literal here. Here will be the class name and constructor parameter string. So that's it, nothing special. At the end, what we need to do is we need to build a file, and inside of this file, we actually generate this file, right? The compiler will generate it for us. We just define the instructions. We build the file, we provide the name and package where this file will be located. We add a type, which is our class. We add type here, it's like a class, right? We add a function, and we build it, and then we write it. So we use code generator to write the file. So actually generate it and put it into the file system. And here we have really important stuff, so dependencies. So dependencies object is part of Kotlin Symbolic Processing, and this is kind of an optimization. So how it works. If we provide dependencies with some sources, and we're saying that these sources are aggregated is true, that means every time we change our DTO class in our code, the build system, the compiler, will regenerate the output, but only this output. For example, if I have 10 DTOs and I change only one, then during the build stage, only one model class will be regenerated. All 9 others, they will leave untouched. And this actually saves a lot of time if we scale this solution, not to 10 classes, but for example, 10,000 classes. You see? So yeah, this is one of the important optimizations, and it's really important to know it. And that's it. So yeah, let's quickly take a look at our sources. So here, as you can see, we have some class which is called billing data DTO. It has ID, account name, due date expired, whatsoever fields. And I want to have a model. So just to demonstrate you, we don't have billing data model right now. But if we build this project, yeah, just a second. Okay, so we built it, and right now in a build file, in generated folder here, you can see that we have a billing data model. So this was automatically generated by KSP for us, alongside with this extension function, which is a converter for our billing data DTO. Okay, so now we can, at least now we have a model in our class path, and we can say that some billing data DTO object could be converted to it. And yeah, this is how it works. So this is kind of a real example of it. So yeah, I also have tests to demonstrate, but probably let's leave it to the final section of questions. But yeah, tests here work. They are kind of a plain unit tests, and you can test your functionality of your processor easily to make sure everything works okay. All right, so back to the slides. Best practices. So yeah, as I already mentioned, pay attention to dependencies object. It could save a lot of time for you and not for you, for your teammates, for your project, for everybody, right? We need to limit number of traversals through the source code. So you should try to do everything in one traversal just because of your source code base, right? It is very big. So if you need to go through it a couple of times, well, it will require some time and it will slow your build speed of your project. Here is a link to KSP class diagram picture. The link is also duplicated in sources slide at the end. So you can check it out and actually evaluate if something is feasible, like you have some thought how you can optimize or use KSP on your project. First, check out this diagram and understand if it is feasible to do or not using the KSP. Just because it might be not. You probably need a compiler plugin in your case. So who knows? Better to check first. Use Kotlin Poet or Java Poet in case you're using Java annotation processing. This is actually making your life easier. A lot of stuff is already written in this library and you can utilize its APIs. Be aware of several lines of processing, especially if you have some couple of processes which depend on each other. And yes, always cover processing logic with tests. And this could be a more general advice. Cover your logic with tests everywhere, not only processing, but in your real code on your projects too. So conclusions. And this is kind of a really important slide, probably the most important here, when you need to use a KSP or any other annotation processor. So there are like 3 cases, A, B, C. So if you want to replace a boilerplate code with automated code generation, and like this is not possible with template agents. Again, if you don't know about template agents, go and read about them. Really powerful tool, really powerful tool. Saved a lot of time and money for a lot of customers and clients for us. So yeah, if it is not possible, well, probably you need to use annotation processor. If you have something like for each class X, for each file X, you need to change some Ys, well, it might be the sign that, well, annotation processing could also help you in that situation. And to validate something that is not possible or reasonable to validate with lint. So you could also rely on the annotation processor. But even in these 3 cases, you still need some of the next questions to have positive answer, right? So will it take less time to implement a custom annotation processor than manually do the thing next time? And this is a question of scalability of the project, right? If your project is a really small one or a medium one, and you don't expect it to grow significantly, sometimes it's better to go like directly and create something manually, just because you will spend a lot of time for the annotation processor. Besides, you probably will need to support it in the future. This is also supporting costs for this solution. So you should think about a couple of times before you actually implement it. And another question is that, does the subject to be processed always have the same procedure of processing, right? And the only changing piece is input. So just because in case it is not, and you have some kind of a variety in your logic or conditions, well, in that case, probably the annotation processor will not be the solution for you. So yeah, that's it. Here are the sources. They are clickable, but you can't click your screen. That's why here's a QR link. You can use it. It will redirect you to the page where these links available right now. And yeah, this is it. The second image, if you still remember about the riddle I mentioned at the very beginning, here is the second image. And if you have both these images in your mind, here is the riddle for you. So what is the real-time, the real-world technology for the annotation processor that you could think of looking at these 2 pictures? So yeah, if you have some thoughts, bring them to the comments section. Yeah, I will give you a couple of, I don't know, seconds because we don't have a lot of time. And then I will provide you some answer for this riddle. Well, generally, it's a kind of hard question, right? To think about these analogies, but for this particular one, this is kind of so the man was a spy, right, or a detective, and the answer is that you have some encrypted message and the key is somewhere inside the message, then as an annotation processor, you can get the source, use the key as an annotation, and produce some more data from these sources, modify it in a way like the annotation processor does. But yeah, that's kind of a not a real world example, but still a good analogy for the annotation process. And that's it. Yeah, thank you very much for your attention. And yeah, thank you. I will be happy to answer your questions.
Thank you, Evgeny. Quite good analogy that you showed. So all in all, I see that annotation processing is a very powerful instrument, and I surprised that your live demo works smoothly. Yeah, usually it goes not so smoothly. But a question that I wanted to ask is about what happens if we write wrong code, let's say with some mistake. Will it generate a class, or will it, let's say, show your errors or something like this?
Yeah. So as you could see at the slides I've shown, when we generate my code, this code goes through the steps of analyze and parse analyze once again. So that means that compiler will check the syntaxes for you for generated files. And yes, the file will be generated, but it will have syntax errors, and the compiler will stop compilation process and will report that you have syntax errors in this file, in the generated file. So yeah, that's what will happen.
And as a result of compilation code, we can see them in build folder, yeah?
Yes. Yeah.
Okay. So yeah, guys, please, we would be happy to answer on your questions. We have live chat in YouTube. Do not hesitate to ask anything related topic, related annotation processing. And so as you shown on the presentation, the KSP works faster than Java annotation processing. X2 boost, yeah, that claimed Kotlin team. But recently, I know that Dagger, the popular library, started to support KSP, and there are several developers who tried to test it, didn't see big significant, let's say, improvements in speed. What's your thought on this?
Yeah.
Mhm.
Yeah, I think that first of all, KSP boost comes from for the Kotlin files, right? If we compare Java annotation processing for Java and Kotlin and Java annotation processing for Kotlin, right? In that case, we've seen and we've had this pain that the compilation times and build times become slower. And that's the reason, the root reason for that is that Kotlin files by the Kotlin compiler are transformed to some temporary files in Java. So the Java annotation processor could go through them. And then when it ends, these temporary files, they're kind of deleted. So this is kind of another intermediate representation of Kotlin files just for annotation processor, for Java annotation processor. So if this stage takes a lot of time, right? Let's divide it by percents, right? If you have annotation processor, which processing logic takes 20% of time, and 80% of time for the Kotlin files, it will be for generating these stubs, these temporary stubs. Well, in that case, when you switch to KSP, you will just remove this 80% of time spent by the Java annotation processor for actually processing your code. For Dagger, I believe generating these intermediate Java representations of Kotlin files, it doesn't take a lot of time for the Dagger annotation processor, just because generating the files, the dependencies, right, the files which define our dependencies and how we create them for the dependency container, it takes the biggest amount of time or bigger amount of time than generating these stubs. That's why probably the speed time boost is not so significant for Dagger using KSP. But at the same time, I know that for Glide, it's kind of a 30% faster or 40% faster if you're using KSP, if I remember correctly, if it was Glide, right? So what I'm trying to say is that for some of the libraries and frameworks, transition to KSP really makes the difference. So yeah.
Yeah, thank you for your clarification. Now I understood this problem better. But from your point of view, is it a necessary knowledge for a senior developer? I mean, how annotation processing works?
I would say that overview is great to have this overview in your mind, at least like some pieces of it, just because in that case you understand better where you have these penalties for the build time and compile time, and what are the consequences of using some library which is reliant heavily on annotation processing. But in general, I'm pretty sure that a small fraction of developers, like even if we take only senior and leads, even in that categories, a small fraction of developers have to actually work with any annotation process, and like I've shown to you, right, to create some annotation processor for the project or something like that. So these are kind of a specific knowledge, which good to know, but it's not mandatory at all. I would say it like that.
Yeah, maybe it depends also on the project specific, and special requirements that people have. You also provided a quite good guide when we should use annotation processing, but let's say it's still not clear for me what are maybe real practical examples. Did you have such experience to start writing annotation processing code in your life, or you can maybe provide a practical example when it's really reasonable for some libraries or for what?
Yeah, we had a couple of use cases, but in all of these use cases, the queue was so long that we didn't even consider using a Kotlin annotation processor or Java annotation processor, just because there are a lot of options before. One of these options are template engines. As I said, you can use they are built into your IDEs. You can use different scripts, for example, if you need to generate some code. In our case, it was kind of a plugin for the Gradle, I believe, which generated for us some pieces of a module. So we had a modularized project where each screen or each piece of data had its own module. And for these modules, we know that there are some set of classes which we always need to generate, and we can define the name. So we were relying on this instrument, right? But in cases when you want everything to be tight, and when you need probably to analyze a source code you have, right? Just because when we use annotation processing, we are looking at some source code we have and generate something on base of this source code. So in that cases, yes, it might be your choice. So if you need to generate something from the scratch, yes, there are a lot of tools, as I said, template engines, some scripts, Bash, Python, whatever you like, right? For some examples, for some cases, we can use, as I said, plugins for the build tools. They could also provide you some valuable tooling and APIs to generate some classes. But in case you need to build something on top of your sources to eliminate boilerplate or to not make it by hands manually, then yes, annotation processing could be a good choice for you. Unless, as I said, you have to modify the source code during the compile stage. In that case, yes, you need to use the compiler plugin probably. So yeah.
I can also add that if you'd like to write code in annotation processing style, you should join to open source libraries or contribute to existing libraries. Yeah. So, by the way, you showed a good example. Is it, let's say, is it possible to provide a link? Do you have it in GitHub or
Yeah.
somewhere?
So there was a QR code with the links to the source code.
Yeah,
So
I see. Oh, okay. Yeah, in this case, we will add at the bottom of this video links to GitHub and other sources that Evgeny mentioned, because yeah, your code not working for everyone. And maybe the last question from my side, I've heard that some people compare KSP and reflection. Is it comparable, or can you maybe elaborate more on this?
yes, it is. And it is, well, basically almost the same. So you have really similar tooling, right? Using the annotations, you can go through the tree and the elements that are annotated. You can get the class, parameters, functions, everything. So this is available just because compiler has access to your code, and it can build a tree of your code. When we work with reflection, almost everything the same, right? We can get a class, we can, from using the reflection from this class, we can get its name, what it consists of, parameters, we can even invoke some methods. And they're similar, but you need to understand, again, the penalties you could pay for that in case you're working in environments where you have a limited amount of memory, limited amount of CPU, a limited amount of battery in some cases, right? Then working with annotations, working with reflection, well, it is not a really easy operation. It is kind of a heavy and treated as heavy. So it can slow down the performance of your application. And yes, if you're a backend developer, well, you have a lot of resources. You can use reflections and do the stuff. But for the front-enders, KSP and annotation processing could be the choice, just because, yeah, I mentioned these reasons.
Yeah, thank you. Thank you for such quite clear explanation. So I see in our chat only reactions. Yeah, guys, please write any comments, any reactions. Seems so that they have no questions. On that note, let me say thank you, the auditory, for being with us, and many thanks to our speaker, Evgeny Kovalov, for such inspiring presentation. Guys, let's keep in touch. If we need, let's say, you need to know more about annotation processing, please find Evgeny in Microsoft team chats at our company, TPAM, or write something on YouTube. I contact you directly to Evgeny if needed. So yeah, on that note, let's finish our talk, and thank you again.
No
Have a nice
problem.
day. Bye bye.
Guys, bye.